All right, welcome back to the next video in the series of Algebra 2 distance learning stuff. We're going to continue on using with exponential and logarithmic equations this week. And so last week we talked about solving log equations, and today it would follow that we're going to talk about solving exponential equations. So just like always, good idea to have a piece of paper and something to write with as we go through some examples. I'm going to ask you to pause the video a couple of times and do a couple of them on your own just to make sure you kind of get the feel. There's really only two methods of this. So we're going to kind of hop right in and do some examples. So before I do that, a little bit of comic relief, at least things that I find funny. So here's one meme that I found about exponential equations, which you might know if you watch YouTube every now and then. Of course, if it goes 2 and then 4, in a couple of years, we're going to have 206 of them. So hopefully that doesn't happen. And then I found this one too with an old friend, Grumpy Cat. Yeah, I don't know. If you don't find those funny, then we just have a different sense of humor because I think they're pretty funny. Anyway, so let's go on to the first method of finding solutions for exponential equations. Okay, so method 1, I'm going to call this method 1A. Because we're going to see something else in just a minute. I'm going to call it 1B, but anyway. So if the bases are equal, all you have to do is then just set the exponents equal to each other and solve. So something like this, you get 2x to the minus 4 power equals 2 to the 7th. Now, since both bases are 2, we just have the two exponents equal to each other and we're done with it. So x minus 4 equals 7. Everybody knows how to do that. Add 4 to both sides, so you get x equals 11. Another example, 6 to the 3x minus 5 equals 6 to the 7 minus x. Again, as long as those bases are the same, we can just kind of ignore those and then just deal with the exponents. So you have 3x minus 5 equals 7 minus x. And again, just do your algebra. And you end up with x equals 3. And that's going to be the solution, okay? But what if the bases are not the same? And this is kind of what I call method 1B. Then you got to think to yourself, well, is there a way that I can rewrite it so that the bases will be the same? And the key part of this is know your basic powers. Know your second, third, and fourth powers of like 1 through 5. And you should be able to get these pretty quickly. So here's an example. So let's say we have 10 to the 3x minus 7 power equals 100. Well, how can I rewrite 100? Well, I can write that as 10 squared, right? So all of a sudden now the equation looks like this. The bases are the same. So this is our first method that we had. So we just set 3x minus 7 equal to 2. And then just solve that from there. So x equals 3. About 5, how about this one? 5x to the minus 3 power and 25 to the x minus 5 power. Well, I can rewrite 25 as 5 squared. So rewrite that. Now, in this case here, we do have to remember our exponent rules, right? So the left-hand side stays the same, but notice the right-hand side would be 5 to the 2x minus 10. Don't forget that rule, that's what we call the power rule. So you might have to do that sometimes too, okay? But now the bases are the same. Now the exponents can be set equal to each other. And again, just work on the algebra to get your solution, in this case, x equals 7. And of course, sometimes you may have to change both bases. So you have to look at the problem and say, okay, how can I write them both as the same base with different powers? Okay, so how about this? So we have 8 to the x power equals 16 to the 2x minus 1. How can I write 8 and 16 with the same base? Well, in this case, 8 could be 2 to the 3rd power, and 16 could be 2 to the 4th power. Okay, so we write that, and make sure you use parentheses. So I'm going to write that as 2 to the 3rd parentheses to the x power, and then 2 to the 4th, parentheses, to the 2x minus 1, and then apply my power rule. So it'd be 2 to the 3x, 2 to the 8x minus 4. And now we can set the two guys equal to each other. And then solve it from there. And of course, sometimes you will get fractions. Fractions are people too, so don't freak out if you get fractions. Okay, so that's everything about method one. So I'm going to give you two examples here. Go and pause the video and try a couple of these on your own. And I'll zip through the solutions here in just about 5 seconds. Okay, so hopefully you got those two solutions. So again, so if you look at example 6, there's nothing to do here. All we got to do is set the exponents equal to each other to solve. So you got 3x plus 5 equals x minus 11. And then go from there. So in this case, x equals -8. And then on the second one, here we have to have a little, the bases are not the same. So we got to look at 27. And of course, 27 is 3 to the 3rd power. Use your exponent rule. And then set the two exponents equal to each other. And solve. Okay, so that's everything about method one. So just make the bases the same if they're not already, and kind of be able to go from there. But clearly, there's going to be some times when the bases cannot be written as the same base, right? So what happens then? What happens if there's no way to set the bases equal? Well, in this case, we're going to use the definition of a logarithm, which we saw a couple of weeks ago, and I'll put it up here again for you here. So you should know how to do this. You should be pretty comfortable with this already. But all we're going to do is we're going to just rewrite that as a log, and then basically we're going to leave it like that. So it's very rare that these will come out clean. And even if you don't have a calculator or don't have access to Desmos or whatever like that, not going to worry about decimal answers at all. We're going to leave it in terms of a log. Okay, so example 1 will just be this. So how would I write that? So 2 to the x power equals 7. No way to write 7 as the power of 2. But how would I rewrite it as a log? Well, using the definition, this would be log base 2 of 7 would be equal to x. And guess what? You're done. That is your answer, and it's 100% acceptable to write it as a final answer. Okay? Now, if you have a calculator or using Desmos or whatever, if you put that in the calculator, log base 2 of 7, it's going to throw a decimal at you, about 2.807. I don't even want that, and this is the only one I'm going to give you the decimal answer on. The other examples, I'm leaving just as a log. Okay, so I really don't want the decimal answer, even on the assignment. So a couple more examples of this. So remember, sometimes you may have to do some things on the end. So in this case, I got 3 to the 2x minus 1 equals 20. Can't simplify it anymore. So I'm going to use it as a log. Log base 3 of 20 equals 2x minus 1. But I still want to get x by itself, right? So I need to add 1 to both sides and then divide by 2. And so that's it. So x is equal to that quantity, log base 3 of 20 plus 1, all divided by 2, and you're done. I do want to make sure that you see that you cannot combine the 20 and the 1. That's why I put the 20 in parentheses. So don't get carried away with like simplifying or trying to simplify something that you can, because that's going to be your final answer. Okay. Let's take a look at another example. Now, sometimes you may have to do some stuff before you use the definition. We'll take a look at this one. So I can't use the definition until I've isolated the exponential part. Okay, so the first thing I got to do here is subtract 5 from both sides. And then I got to divide by 3. Okay, once I'm there, now I can use the definition. So log base 2 of 3 equals 7x minus 1. But again, I got to get x by itself. So I'm going to add 1 to both sides and then divide by 7. And again, nothing else I can do simplifying wise. That's going to be my final answer. Okay. So again, I've got a couple more for you to do on your own. I'll put the definition up there, but you should know that. So pause the video one more time and see if you can do those by yourself and get that solution. Again, you don't want decimal answers, leave in terms of log, and we'll go through the answers in about 5 seconds here. Okay, so on the first one, example 4, so again, we need to isolate. So add 9 to both sides and then divide by 2. Use the definition and then get Exponential. And that'll be your answer. Same thing on number 5. So subtract 3 from both sides and then divide by 4. And notice when you divide by 4, it ends up being 3 over 2. Okay, to get a fraction on that intermediate step also. Okay, we can still write that as a log. And then we need to isolate the x. So all I did here, I added x to both sides and subtracted the log from both sides. So the x is going to be equal to 6 minus log base 2 and 3 over 2. Okay, so that's all there is to solving exponential equations. So just to kind of recap, method 1, if the bases are already equal, super easy. Just set the exponents equal. If they're not equal and you can make them equal, go ahead and do that. Just again, keep in mind you've got to know your powers and don't forget your exponent rules when you're simplifying that. And then of course, method 2, if the bases are not equal and there's no way to make them equal, that's where you just write it as a log and then make sure and get the x off. Okay. So hopefully you found this video useful. There is going to be an assignment posted for the week on just solving these kinds of exponential equations. Feel free to share this with anybody else in Algebra 2 going through the same thing. Feel free to subscribe if you like to. And until the next time, keep studying.